Now, here's the new chapter we're going to get started with measures of center. The concept, first and foremost, is to obtain a value that measures the center of a data set, present and interpret measures of center, including a mean and median. This is the summary that we're going to look at. The idea of measure of central tendency refers normally to the following: finding the mean, median, mode, mid-range, weighted mean. A measure of center, in general, referring to a value at the center or middle of a data set. Let's start with the one that I think everybody is familiar with, known as the mean or arithmetic mean, sometimes be referred to as average, but normally in statistics we use the terminology the mean. So the mean or arithmetic mean of a set of data is the measure of center found by adding all of the data values and dividing the total by the number of data values. Simply put, add them up, divide by size. Important property.
Sample means drawn from the same population tend to vary less than other measures of center. The mean of a data set uses every data value. The disadvantage of the mean is that just one extreme value outlier can change the value of the mean substantially. Using the following definition, we say that the mean is not resistant.
Resistant. A statistic is resistant if the presence of extreme values or outliers does not cause it to change very much.
So in short, what really happens here is that, remember the basic way we calculate the mean, and because we include every piece of data, then it is affected by outliers. And that's why I mentioned before that sometimes we use what's called a trimmed data, where we cut the top and the bottom 5%. Remember, that's in case it's doable and we have enough data. All right, let's look at the symbols that are used here. This is to make sure everybody's comfortable with the notations. The first one, obviously, is the summation notation. Everybody remembers that from algebra. Normally, we use X to represent the variable, an individual piece of data. N is the sample size, lowercase n. And we use capital N to represent the population size. So what happens in statistics, the way we use the symbols are different, and that's important for everybody to know that. And later on, it becomes extremely important for everybody to see how this thing plays out. So it's important to understand the symbol. So having said that, X bar is the symbol that is used for sample mean. So what we use Latin to represent symbols of sample, whether it's sample mean or sample standard deviation, so on and so forth. You'll see that's become a crossing. Whereas for the population, we use the Greek letters. So in this case, we use mu. Mu is pronounced mu, mu, and is the mean of all values in population. So again, what really is important for everyone to know, because we want to distinguish between a sample and a population, we also use different notations. That is extremely important.
The data represents the number of days off per year for a sample of individuals selected from 9 different countries. Find the mean.
We want to find the mean. And if you look at the top right, I have given you the formulas. You are, I think, familiar with the concept. You know how to find the mean. But it is important to know that it is a sample, okay, just a few, and therefore we use X bar or summation of X over. Now this is a very simple calculation. Simply put, add them up, divide by size. So we add them up and we divide by 9. And again, you may have 2 days off, 5 days off, 10 days off, 15 days off, or I don't know, 100 days off. But on the average, we can say we have 30.7 days off. I've mentioned that before. Again, you can't say I have 2.5 cars, but you can say an American household has 2.5 cars on the average. So that's important to understand as far as how we can use this. So with that being the case, one thing I want to also mention is that sometimes they use lowercase, sometimes they use uppercase for the X bar, depending on the text that you're using. Median.
Median. The median of a data set is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. In other words, the median is the midpoint of the data array.
So that's the definition of a median, just middle of the data if it's ranked from small to large.
The median does not change by large amounts when we include just a few extreme values. So the median is a resistant measure of center. The median does not directly use every data value. For example, if the largest value is changed to a much larger value, the median does not change.
Yeah, that's why they call it resistant. That's why in many cases they may use a median to discuss things, for example, the average income or the average cost of a house, because there are definitely outliers. So in those cases, for example, normally they use the median. And finally,
to find the median, first sort the data in ascending order. If the number of data values is odd, the median is the number located in the exact middle of the sorted list. If the number of data values is even, the median is found by computing the mean of the two middle numbers in the sorted list. Given the data speeds 38.5, 55.6, 22.4, 14.1, and 23.1, all in megabits per second, find A, the mean, and B, the median.
So we want to find the mean. We do have the formula at top. We use the x bar equals summation of x over n. It's a simple calculation. All we have to do, add them up, divide by the size. There are 5 pieces, and we get 30.74 megabits per second. Now, one of the things that I want to mention about the rounding, if you do the rounding early, you get what's called round off error. But they have a specific rounding rule. You want to follow that for the sake of getting the homework and exam questions correct. And that is normally 1 digit more than the given. If you see there is 1 decimal for the given data, so we add 1 more to find the average. All right, in order to find the median, you simply put them in order from smallest to largest. And the middle of the data is 1 number. And this is how it's calculated, class. You look at for the middle of the data, and this is a case with an odd number of data. In other words, 5 or 5001. It doesn't matter. It's odd. There is a number in the middle, and that is your median. However, if it happened to be an even number, then you don't have any number in the middle. So you find the 2 numbers in the middle, and you take their average. That's the idea that was discussed in the previous page. What is the meaning of the mode?
The mode, sometimes called the most typical case of a data set, is the value or values that occurs with the greatest frequency. The mode can be found with qualitative data. When no data value is repeated, we say there is no mode. There may be no mode, 1 mode, 2 modes, or many modes.
Okay, so mode simply means the one with the highest frequency of occurrence. That is the simplest way to define it. Mid-range.
The mid-range of a data set is the measure of center that is the value midway between the maximum and minimum values in the original data set. Because the mid-range uses only the maximum and minimum values, it is very sensitive to those extremes. So the mid-range is not resistant.
It's very straightforward. You just add up the minimum and maximum divided by 2, and it can't get any worse than that when it comes to using the outliers. That's why in practice, the mid-range is rarely used. It helps reinforce the very important point that there are several different ways to define the center of a data set. The value of the mid-range is sometimes used incorrectly for the median, so confusion can be reduced by clearly defining the mid-range along with the median. So mid-range is simply the sum of the min and max divided by 2. We are looking at the data, and we have now the same data. We added one more. We want to calculate mean and median, and we are adding the mode and mid-range. So the mean is very simple. We add them up and divide by size. Again, x bar, not mu, simply because we are dealing with a sample. The median, let's rank them first. When we do that, we know the size is an even number. So right here is the median. What does it mean? Between the two numbers. So because it's an even size, therefore we have to add them up, divide by 2. So that's how you would deal with the median when the size n is an even number. There is no mode. Why is that, class? Can anybody tell us why there is no mode?
Because no data value repeats.
Perfect. Nothing repeats. And to find the mid-range, all you have to do, add up the minimum and maximum and divide by 2. Now, here's what I want to add. This is extremely important. You don't need to sort or rank the data in order to calculate the mean. However, I suggest you do that. If the question is asking for the median, mode, and mid-range and other stuff, before even you calculate the mean, sort the data just to be on the safe side. I've seen students making a mistake with that. They would come up with the wrong median, they would come up with the wrong mid-range and range. Later on, we discuss that. So my suggestion is just to be on the safe side, even when you don't need it, rank the data. It is really helpful.
I have a question.
Sure.
Why do we have 4 significant figures for the median mid-range, but we keep it at 3 for the average?
Well, it's just the number of decimals. If you look at the data has how many decimals?
It has 1.
1. So over here, you add 1 more. And this number, if you write it as 29.70, is the same thing, because when you divide, you get 29.7. You don't have to write it as 29.70. When you have to do the rounding, you round it to 1 more place. This is how they do it for, again, as I mentioned, for the sake of the text. I want more decimals. If you look at practice tests, I put more decimals. But this is the way they do the round.
Okay.
Now we have a different set, and we are asked to come up with the mode. It's a very straightforward question. It is already ranked. It is sorted from smallest to largest, and we can clearly see which one is the mode. So as you can see, 0.3 repeats more than anything else. Now, bear in mind, 0.6 repeats 2 times, but it doesn't mean anything. Okay, you're looking for the one with the highest frequency of occurrence. How about this case? Although it's not ranked, it's not sorted, so this one happened to happen 2 times, and this one happens 2 times. So we have 2 modes, or it's called bimodal, 2 mode. We have the following pieces of data: 0.3, 1.1, 2.4, 4.0, and 5.0. So what's going on here?
No
We
mode.
have no mode.
Simply because nothing repeats. So there is no mode. Well, this is the question that was just asked. Rounding rule. The mean, median, and mid-range should be rounded to 1 more decimal place than it occurs in the raw data. I want you to see something, and that is, this is the way in many texts they do it. In some texts may not follow that if you were doing it, but whenever you get on to do your homework and exam questions, you're going to stick with the rules they have to get 4 credit.
The mean in most cases is not an actual data value. For the mode, leave the value as it is without rounding, because values of the mode are the same as some of the original data values.
Okay, finally for this page,
Caution, never use the term average when referring to a measure of center. The word average is often used for the mean, but it is sometimes used for other measures of center. The term average is not used by statisticians, the statistics community, or professional journals.
so that's normally the case when it comes to statistics. although we are used to it, and sometimes we use, okay, find the average, and we did that when we did it in algebra, so we want to be careful. So here's a frequency distribution table, and we want to find the mean. Let's see how it's done using a frequency distribution. Mean from a frequency distribution. Multiply each frequency by its corresponding class midpoint. Add the products and divide by sample size. This is the formula. We are adding x bar equals summation of f x sub m divided by n. Sometimes they use x, sometimes they use x sub m. Notice I am using x sub m with the formula, but if you look at the table, I have f times x. I did that on purpose because I want you to see there are various ways depending upon the text that you're using. They may use just x to represent the midpoint, okay? That's why if you look at the third column, I called it class midpoint x. Sometimes even use m to represent the midpoint, and sometimes they use x sub n. Again, I'm telling you all of that because if you come across a case where the notations are slightly different, we don't want to be confused. Now, the idea is very simple. Remember, when it comes with the frequency distribution table, we don't have every piece of data. For example, if you look at the first class, it says between 75 and 124, there are 11 pieces of data. It could be that all of them are 75. It could be that all of them are 124, or it could be somewhere in between all over the map. We have no idea what each piece is, but I hope everybody understands the meaning of the frequency distribution table. So in calculation, we have no idea what each piece is, so the best guesstimation would be to use the midpoint. So the very first thing is we calculate the midpoints. How do we calculate the midpoints? Lower limit plus upper limit divided by 2. So for example, the first class is 75 plus 124, which is 199, divided by 2, which gives us 99.5. And by the way, I hope everybody remembers that we can easily see, if we go this route, this is from before. The width is 125 minus 75, or 124 minus 75 plus 1 unit. And the width is 50. So if the first one is 99.5, the rest of them I don't have to calculate. I add them up. I add what? The width. So I hope you see all you have to calculate is the first one, 99.5. Then it's a simple addition of 50. Now, I'm looking at this formula, and this formula says in order to calculate the mean, you have to multiply them, add them up, and divide by n. So that means now the second column must be multiplied by the third column. So 11 times 99.5, 24 times 149.5, and the rest of it. So you multiply these two, you get 1094.5, and the rest are calculated in the same manner. And what do we do now? We need to have the sum of the frequencies, and we have it. We need to have the sum of this last column. We add them up. And so we divide the last calculation we just did, the summation of fx, which is 8025, by the total sample size n, or summation of f. This is n, and that gives us the answer. Now, a couple of very important observation before we move on. Is this going to be the same as the actual mean? Remember, what is the actual? The actual mean, you should have the original data, add them up, and divide by size. That would be the actual mean. But this result, the result of x equals 160.5, is an approximation. This is really expo. Why is that? Because it is based on the use of class midpoints, not the original values. We don't have everything there. So that's one very important observation. Now, what about the next one? Mean from a frequency distribution. Calculation is made by pretending that all sample values in each class are equal to the class midpoint. That is the assumption, and remember, that's really not a fact, but we don't have any other choices. Do you take the lower limit? Do you take the upper limit? No, a good choice would be somewhere in between, and that would be the class midpoint. Go ahead.
I just have one question for the last problem. What was the significance of using the width?
In order for you to go from one midpoint to the next, for you to move down here, you have two choices. Calculate each midpoint, meaning for the second one, 125 plus 174 divided by 2. For the third one, 175 plus 224 divided by 2. Are you following that?
Yeah.
But instead of that, isn't it faster to add the width of 50 to the first one and go all the way down?
Oh, okay. Yes. Yeah.
Does that make sense? And that's why I suggest we use that.
Okay.
Now, we're going to repeat that first for the mean just to refresh your memory. How do we find the mean? We are using the top formula. X bar is the summation of fx sub m over n. Now I'm using x sub m. Again, I'm doing this on purpose. So depending on the text, you have different variables used. So with that being the case, you need to find the midpoint for the first class. That means what? If you add these two, you get 5.5 plus 10.5, which is 16 divided by 2 is 8. Now, can anybody tell me what is the width?
5.
Very good. 10.5 minus 5.5, which is simply 5. So if the first one is 8, I don't have to calculate the next one by adding and dividing by 2. I just keep on adding 5. So I hope you see it's a lot easier to add 5 than adding them up, dividing by 2. So this is a faster method. Now we are going to multiply column 2 and column 3. So let's call it column 2, column 3 to get to column 4. So the first one is 1 times 8 is 8. The next one is 2 times 13, which is 26, and you have the rest of it. Now, when we look at the formula at the top, this formula tells us we need n. So the second column we need to add up. We need summation of the numerator fx sub m. That means the last column we need to add up. And so simply divide sum of column 4 over the sum of column 2, and that's x bar. Now, the next one, it says, what is the modal class? As far as the definition of a mode, it works the same way. Remember, the mode is what? The one with the highest frequency of occurrence. So which class? It has highest frequency. The frequency number 5 is the highest, so that class has the highest frequency because 5 is the largest number among the frequencies. So your modal class is that one. Now, what is the mode? Again, what they do, they find the midpoint of that class. We already have the midpoint. So the mode is the midpoint of the modal class. That's how it is calculated. I want to look at a very important topic, especially for students, because your GPA is calculated in this manner. So we are going to look at weighted mean, or you can call it weighted average.
Find the weighted mean of a variable. Multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights.
So here's the formula. I want to make sure everybody understands why we do that. Think about this concept of a GPA that is discussed. First, let me just put up this example. We want to find the GPA for a college student who took 5 courses and received A. That's a 3 credit or 3-unit course. Another A, it's a 4-unit course. A B, a 3-unit course, so on and so forth. Okay. Now, why is it important to do the average in this manner called weighted mean? If you happen to have only 2 courses, I want to make sure we understand what's happening. If you have only 2 courses and one of them is A and one of them is B, remember A is normally used as given a value of 4.0 and B is given 3.0. So if you have one of each, one may be under the assumption that 3.5 would be a proper, but it really depends on the course. If a course was worth 5 points when you received an A, and the one that you received the B was worth 2 points, then it's not fair. And that's the idea, because it's weighted more. The weight on that 5 unit is, you can think of it as the weight as 5, whereas the 2 unit course, the weight as 2. So with that being the case, and again, A is worth 4, B is 3, and go down the road, and we have these values we should know. And look at the table that we have. The weight would be the number of units, and X is the value. So number of units and the value. So you multiply the first column, which is the weight column, by the second column, which is the value column or the X column, and you divide by the total weight. And this is how it's calculated. But what is important is what you put in the denominator is the total number of units, and you have your GPA. This is how GPA is calculated. We want to calculate the GPA here. Let's discuss the concept, because that's really what matters. That's important. And the concept is identical to the previous question. Now, understand the difference is, the table is given to us. It's a lot easier than before, because on a normal basis, you have to come up with the table. So you have to create this table. Over here, it's given to us. The weight is the number of units. And normally A is worth 4 points and the rest of it. And you go down, B is 3 points, C is 2 points, and so forth. So you have to multiply those two columns, and that would be the sum. You divide by the total number of units. That's how GPA is calculated. And as far as the distribution is concerned, if the distribution is symmetric, so I want you to look at this one first. The mean, the median, the mode, they are all happening at the same time. Now, what happens when it's skewed? Well, the mean is affected by the outlier. So this is skewed to the right. There's an outlier towards the right. That's why the mean happens towards the tail, always. So the mean is happening towards the tail. The median is in between. The one with the largest frequency is the mode, and that would be the tallest.